Everyone, in this tutorial we are going to take a look at how to do some of the basic matrix operations numerically using Python. So first off, we need to import Numpy for our computations. So today we will take a look at these matrix operations, which is basically addition and subtraction, matrix multiplication, transpose and adjoint of a matrix, getting the determinant and inverse, and finally finding the eigenvalue and eigenvector of a matrix. Now, these can also be done on both real matrices and complex matrices using Numpy. So here I am defining two matrices to work with. So my matrix A would be a complex matrix and my matrix B would be a real matrix. And as you can see, we write the complex numbers in Numpy using the small letter J. And we always need to put a constant before it, unless the constant is 0 and there is no imaginary part. So let me start with defining the matrices. And the first one is pretty easy, getting the addition and subtraction. It's just numpy.add and numpy.subtract, and that gives us a plus b and a minus b. And then for the matrix multiplication or matrix product, we just do numpy dot dot, and we plug in whatever matrices we want to get the product of. And as our matrix A is complex, we can see that we have a complex product. So adjoint of a complex matrix would be the transpose of its complex conjugate, and if that matrix is real, then its adjoint would be just the transpose of itself. So we can get the transpose by just writing a dot t, so that would give us the transpose of matrix A. We can get the complex conjugate using numpy.matrix.conjugate, and we can get the adjoint of a matrix directly by writing numpy.matrix.get h in capital letters. And notice that it is equal to the transpose of its complex conjugate. So the complex conjugate here is this, so 1 minus 5j. This is what we have here, and then 3 plus I, or 3 plus 1j here, and we have it here. And then we have this element right here and this element right here. So we can see that the transpose of this complex conjugate is equal to the adjoint of the matrix A. Similarly, the matrix B in this example is real, and we can see that the adjoint of this matrix is just equal to its own transpose. Now we can get the determinant of the matrix. So the code is pretty simple: numpy.linear algebra, which we write as linalg.determinant, and then we plug in whatever matrix we want to calculate the determinant of. And so we have here the determinant of the matrix B. Inverse is also pretty simple: numpy.linearalgebra.inverse, and getting the eigenvalues and eigenvectors. So that is also used using the linear algebra. So numpy.linearalgebra.eig, and that gives us the eigenvalues of B according to their algebraic multiplicity. So here we have one eigenvalue is 1 and the other eigenvalue is 2 with only one algebraic multiplicity, and these are their corresponding eigenvectors. For the matrix A, which is complex, we can see that we get a complex eigenvalue and so complex eigenvectors. And so this is it. This is all the basic matrix operations that you need, and it's pretty simple and pretty easy to get done in Python, and it's really fast. So that'll be all. I'll see you again in the next video. If you like my videos and find them helpful, then please support my work by subscribing to the channel.